In this lesson, we are going to see some of the basic operations that we can perform on 2D tensors. So first and simplest is addition or subtraction. So let's say we have two tensors, both are 2D and both should have the same dimensions in order to perform addition or subtraction, and their types should also be same. So when we perform addition, we add element wise. So both are exactly of the same shape. So this 1 is added to this 2 here, so we get 3. Similarly, 5 is added to minus 5 and we get 0. 2 is added to minus 3 and we get minus 1, and 6 is added to 0 and we get 6. The same thing will happen when we perform subtraction. Now let's see when we do a scalar multiplication, that is we multiply a scalar with a 2D tensor. Let's say we multiply a with 2, so all the elements will be individually multiplied by 2. So 1 becomes 2, 5 becomes 10, 2 becomes 4 and 6 becomes 12. So this is the way of doing scalar multiplication. Next, let's see Hadamard product, which we had already seen in the case of 1D tensors. So if we have two matrices or two tensors, 2D tensors of exactly same size and same type of elements, the Hadamard product would be element-wise multiplication. Just like addition or subtraction is done element-wise, the Hadamard product will be done element-wise. So 1 and 2 multiplied results in 2. 5 and minus 5. If we multiply them, we get minus 25. 0 and 6 become 0. 2 and minus 3 becomes minus 6. We will see examples of all of these in PyTorch also. Now next is matrix multiplication. So in this case there is a condition that the number of columns in the first matrix. So first of all, AB is the matrix multiplication of matrices A and B, which is not same as BA in general. And even if you are able to perform AB, you may not be able to perform BA due to mismatch in the required dimensions. So let's say we want to perform AB, that is A is the first matrix and B is the second matrix. Then the matrix has some rows and some columns. In this case it's 2 rows and 3 columns, C1, C2, C3. So it's a 2 cross 3 matrix. Similarly, B has 3 rows and 2 columns. So the requirement is that number of columns of the first matrix, that is 3 in this case, should match the number of rows of the second matrix, that is 3. These two can be different. It could have been 5 here. So 3 cross 5 is also valid. And the resulting matrix will be, so first we have R1 cross C1 for the first matrix, then R2 cross C2 for the second matrix. So this should be same as C1, this R2, and the result will be R1 cross C2. So the first from this one and last from this one. So in this case we have 2 cross 3 multiplying to 3 cross 2, so we will get 2 cross 2 and the result will be a 2 cross 2, and the first value, that is, so let's call it AB IJ. So IJ means so in this case it's 0, 0. Row, column, these are denoting particular element. So let's say we want ith row and jth column. With the value at ith row and jth column. So we pick ith row from first element, first matrix, and jth column from second. And we have said that number of columns here is same as number of rows here. So let's see, we want to calculate AB 0, 0, that is this value. So we pick the first row, 0th row, and 0th column from B. Both will have equal number of elements. So we do dot product. So 1 is multiplied to 2, so becomes 2 plus 2 multiplied by 1 is again 2 plus 3 multiplied by 0 is 0. So total is 4. So this value comes here. Now for this value, what is this index? Row number is 0, column number is 1. So pick 0th row from first matrix and first column, that is this red one. And again do dot product. So 1 multiplied by 5 is 5 plus 2 multiplied by 0 is 0 plus 0. So it's 5. Next, this one is 1, 0. So first row here, and 0th column here. Again do the dot product. 4 plus 3 plus 3, that is 10. So 10 comes here, and finally we have here 1, 1. So second row here and second column here. So 10 plus 0 plus 2, that is 12. So this is the result, 4, 5, 10, 12. Now let's see all of these operations in our Colab notebook. So we have two 2D tensors, the same example that we saw, and now we perform simple addition. Why is it 2, 3? I'm not sure. Yeah, so it works. I don't know, it was some temporary glitch here. Next, let's multiply this a by 2. So all the elements are doubled. You can see this 1 becomes 2, 5 becomes 10. Similarly, if we multiply element wise, this is the Hadamard product, and you can see that 5 minus 5 becomes 25, minus 25, 0, and so on. And this is another tensor. So maybe I ran this first, so that's why it was picking this value of a. So I had to just rerun this. So that was dimension mismatch. Now we have this a and b, the same example that we saw, and we get the result 4, 5, 10, 12. So it matches with our answer 4, 5, 10, 12.